Hey, it's Marcel. Just wanted to show you our cloud offering for our Tusk Drift product. So obviously we work in CLI. You can do that. You can use that for free to run tests locally, but our cloud product allows you to integrate with CI/CD as well as enjoy some advanced AI functionality for classifying deviations as regressions or intended changes. So very quickly, I'm in a demo repo right now. So I'm gonna do some initial setup. So I'm gonna install my dependencies and I'm gonna run npm run start just to make sure that works. Awesome, cool. And then the other thing I'm going to do is also make sure that I have the Tusk CLI installed, and that is done. Awesome. So at this point in time, I can run npm run start record. And that's going to start my service in record mode so that I can record live traffic to then use as an API test. And the way we do this is by basically storing the full trace. Normally in CLI, that's going to be stored in a temp folder, but in CI, that gets stored in our backend, and you can use a GitHub Actions workflow to run the tests in CI, much like you would for any other automate tests. So in this case, I'm going to actually make an API call to a weather activity API, and I'm going to do this just so I can record some traces automatically. Obviously, as users are actually using your app on whichever environment you initialize Tusk Drift on, this is going to be done automatically. Just for the sake of the demo, I'm going to make that request. Awesome. So now I want to actually show you how Tusk Drift looks like on our SaaS product. So if I go to cursor here, this is the repo that I am working in. So there are a couple of things that I'm making changes here. So for one, I have already created a Tusk Drift init file and sort of initialized the SDK. I've imported Tusk Drift here and also made sure to add this code snippet to mark the app as ready. So that's great. And a couple of changes I made here. So if you go to the diff view, you can see that I've actually created this new function for converting Celsius to Fahrenheit, and I'm actually updating our endpoints as well. So for the sake of the demo, I'm going to show you this buggy branch. So I'm going to create new buggy branch. I'm going to add my changes there. I'm going to commit that. New buggy PR, and I'm going to push that. Awesome. So now I've created that PR. I'm going to go to it, and I'm just going to say introduce API bugs. Awesome. Now that I've created PR, Tusk Drift is going to run on this PR. And so it's going to refer back to my suite of API tests that I have recorded from live traffic, match the ones that are relevant to the scope of this PR, and it's going to give me a breakdown on which tests are passing. So as you can see, it's already run here with 2 tests. And it looks like one test has a deviation, so we can actually click view output to see how that pans out once classification is complete. So we see that the classification of whether the deviation is intended or unintended is happening as we speak. And so I can view this one trace right now. Okay, in this case, if I go to response expected versus actual, there's no change between what the API was responding in the recorded test versus what I'm actually getting back right now. So that's good to know. And if I go back to all results, I can see that that one other test has already been classified, and it looks like it's unintended deviation, which indicates that this is actually a potential regression. So if I go to view details, I see that the description of the deviation is that we're getting different temperature values, and that's affecting the weather recommendations. So it looks like because I introduced that function for converting Celsius to Fahrenheit, it might be causing an issue by changing the recommendation as well, when it shouldn't really be changing that. So I'll take a look very briefly. Again, I can take a look at the HTTP requests, but the thing I care about most here is the diff view between expected response versus actual response. So I can see the changes here is that I have actually changed it to Fahrenheit, but it looks like right now it's actually changing the weather-based recommendations to too hot, even though it's technically the same degrees, just between 2 different temperature measurements. So that's actually really helpful to know. And then obviously if I go down here, I can see the outbound calls that are also made, just so you can see that we're intercepting the outbound requests and also mocking them with previously recorded outbound calls. Awesome. So now I know that that is an issue. We also provide a potential fix. In this case, we either adjust the temperature thresholds to account for Fahrenheit values or remove the temperature conversion altogether to keep things standard. But in this case, it sounds like probably the latter is the thing we care about most. And we also get a code snippet of pseudocode for how we would do this. So we can click copy fixed prompt at the top. And what that is going to do is allow me to then just copy it back into cursor. So in this case, I'll open the cursor window and paste that in and just remove that. And I'll let GPT-5 do its thing with cursor agent. So that's how Tusk Drift works. It's very simple. Once this is done, you would want to copy the CLI command again, run the test locally from within iTerm or whichever terminal that you use. So yeah, that's a brief look at how Tusk Drift works. For $40 a month, you get access to our cloud offering, which allows you to integrate Tusk Drift with CI, as well as enjoy some of these AI functionalities for helping you classify deviations, find hard to detect regressions, and also copy fixed prompts that you can then provide to the coding agent of your choice. Hopefully this is helpful. Thanks so much.